Hello friends, in this video we are going to see design of flanged beams. Question is, a T-beam slab floor of an office comprises of a slab of 150 mm thick spaced at 3 meter. The effective span of beam is 8 meter. Live load at floor is 4 kN per meter square. Use M20 and Fe415 bars. Design one of the intermediate section. So given data is depth of flange 150 mm, live load is 4 kN per meter square, breadth of flange is 3 meter, web width of web is assumed as 3000 meter and effective span is 8 meter. These are all data are marked in this diagram. Depth of flange, breadth of flange, depth of web, breadth of web, and this is overall web depth. Now we must find dimensions which are all not given in the question. First is effective depth. Formula is span by 16. Answer is 500 mm. Next, overall depth. Formula is d plus d dash. D dash is clear cover is 50. So it is 550 mm. Next step is effective width of the flange. The formula is given in the IS456 page number 37. This page is IS456 2000 page number 37. Here is the formula for T-beam and this is for L-beam. So T-beam formula is used in this to find breadth of flange. So breadth of flange answer is 2533 mm is the answer. Next is load calculation. So in load calculation we must find self weight for both flange and web. Flange is horizontal direction is called flange and vertical is called web. So flange is breadth into depth into 25 is the formula. Breadth is 3000 mm. We have assumed it. 0.15 is depth of flange into 25 is answer 11.25 kilonewton per meter. Self weight of web is breadth into depth into 25. Breadth is 300. Depth is 400 into 25. Answer is 3 kilonewton per meter. Next is floor finish calculation. 3 into 0.75. 0.75 is being assumed. We must take less than 1 kilonewton per meter as floor finish. So I have taken 0.75. Answer is 2.25 kilonewton per meter. Live load is given in the question. Totaling it, we get load answer 20.5 kilonewton per meter. Next, we must calculate ultimate load. Ultimate load formula is 1.5 into load. So the answer is 30.75 kilonewton per meter. Step 3 is calculating ultimate load and shear force. Ultimate moment formula is WL square by 8. W is ultimate load answer. So the answer of ultimate moment is 246 kilonewton meter. Next is shear force calculation. Formula is WL by 2. Ultimate load is W. So the answer is 123 kilonewton. Step 4 is calculating moment of flange. Moment capacity of flange. This is to find MU and MUF. MUF formula is in IS456 page number 96, but it is not same formula. We must arrange it. Some minor changes are there in the formula. So here 0.36 df into d minus 0.42 d into df, fck into bf is the formula. Here in IS456 2000 page number 96, here is the formula. This is formula. Instead of XU max, here you are taking it as DF. You must take value as DF instead of XU max by D, and here they have given 1. Instead of 1 we must take it as D. And D square is not necessary in this formula. So we must take D square and 1 is changed as D. XU max is taken as DF. This is to just remind you the formula if by chance you have forgotten it. Calculating in this formula, we get 1.195 into 10 power 3 kilonewton meter, which is 1195 for moment capacity of flange. So ultimate moment answer is 246. Here it is. So ultimate moment is less than moment capacity of flange. Next step is finding tension reinforcement. Tension reinforcement formula is in IS456 page number 96. So this is IS456 page number 96. Formula is here. This formula is used in most of the problems to find tension reinforcement in limit state method. So the AST is 1362.71, which is rounded as 1400 mm square. So next is we must find number of bars. Number of bars formula is AST by small AST. Small AST formula is pi d square by 4. D is taken as 20 mm dia and the answer is 314.16 mm square. AST answer is, here we have calculated it. So number of bars is 4.4, which is rounded as 4 bars. So we are providing 4 bars of 20 mm dia in tension reinforcement. Next step is calculating check for shear stress. This is to find tau v and tau c value. So tau v formula is Bu by B. B is breadth of web into depth. This formula is in IS456 page number 72. So the answer is 0.8 Newton per mm square. Next is calculating tau c. Tau c is calculated by using percentage formula. Percentage formula is AST by breadth of flange into depth into 100. So the answer is 0.11. With the help of percentage in IS456 page number 73 table 19, we are going to find tau c value. So this is IS456 2000 page number 73. This is table 19 and this formula is percentage formula. So whatever value we have got 0.11. So we must find here 0.15, less than 0.15 to 1.15. We must take this value, and in question they have provided M20 bars, so we are taking tau c value as 0.28 Newton per mm square from the table. Now tau v is 0.8 and tau c is 0.28. So tau v is greater than tau c. Since it is greater, there is some conditions which is given in IS456 2000 page number 72. If tau c value is less than tau v, then we must find spacing. So the formula for finding it is we must provide shear reinforcement. So the formula is here vertical stirrups VUS equal to 0.87 into Fy into ASV into D by spacing. VUS formula is VU minus tau C into B into D. This is in IS456 page number 73. If they have given inclined stirrups means formula changes, that is given down. Single bar, single group of parallel bars means formula changes. Here it is. So now for ordinary we must always calculate in vertical stirrups. So the formula is being calculated to find spacing. ASV formula is pi d square by 4. So D is 8 mm dia, answer is 50.27. Calculating in VUS formula, we get spacing 67.49, which is rounded as 100 mm. Next step is finding check for deflection. L by D basic for T flanged beam is 16 and L by D actual is span by depth, whatever value we have got. That is, the answer is 16. So L by D maximum formula is L by D basic into KT into KF into KC. KT, KF, KC values are given in IS456 page number 38. Referring this, I have taken KT value to KC 1.1, KF 0.8. Calculating in this formula, we get 28.16, which is greater than L by D actual. So L by D actual is less than L by D max. Now we must draw flange section diagram. This is flange section diagram. Here we must show the data which are all we have found so far. So now depth of overall depth is 550, depth is effective depth is 500, and we have provided 8 mm dia of stirrups, spacing 100 mm center to center. tension reinforcement is in bottom. We have provided 4 bars of 20 dia. Next is, so this is web and this is flange. Horizontal part is called flange and vertical part is called web. This is the design of flanged beam. Thank you.